So in this lesson, we're going to be looking at products of radicals or involving radicals. And the main idea, this products of radicals, this rule here, is that if you have the nth root of x times the nth root of y, they have to have the same index. That's going to be the nth root of x times y. The index stays the same. Don't do anything with this index when you do this, when you multiply. The index stays the same when you multiply what's inside. We can look through this and multiply these products in really three different ways. We can multiply first and then simplify our radical. We can simplify each radical first, multiply, and then simplify again if necessary. And we can factor, multiply, and then simplify. So we're going to take this first example and show the different ways, these three different ways, and then really what we'll do as we work through here, we'll use what's ever most convenient at the time for the specific problem. So we have the square root of 12 times the square root of 11, and our first method said to multiply and then simplify. So we're going to use that rule, and we're going to take 12 and we're going to multiply it by 11 in the square root. So the square root of 12 times 11, we're going to multiply, that's the square root of 132, and then we're going to simplify this. Now this simplified 132, we want to think what perfect square goes into this, and 4 does. We can actually see that because 4 goes into 12, so 4 goes into this, and 4 goes into this 33 times. And so we're going to rewrite this as the square root of 4 times the square root of 33, and we know the square root of 4 is 2. So 2 root 33. So that's multiplying the numbers together and then simplify. The next way we're going to look at, same problem, but we're going to simplify, multiply, and then simplify if necessary. So let's simplify first. Well, we have a square root of 4. We can rewrite this as a square root of 4 times the square root of 3. Because simplifying, we want to find the largest square root that goes into that, and then times the square root of 11, and so this is 2, and then we have square root of 3 times square root of 11 is the square root of 33. Now we would check if we can simplify that further, in this case we cannot. So 2 root 33. And the last one we're going to factor, and then multiply and simplify. So we have we're going to factor each of these. So this is 2 squared times 3, and then this is the square root of 11. And when we factor first, we can see when we have perfect squares. So what times itself equals 2 squared? Well, that's 2, so we have a 2 out here. And then what's left is the 3 times 11, which is 33. So they're all similar and almost even the same, but we can think through the things different ways. So let's look at another example. In this case, let's simplify so we're not working as big in numbers. If we multiply 8 times 96, we're going to have this large number, and then we're going to try to simplify it from there. So let's simplify each of these first. And hopefully we're getting better and better at these. This is going to be a 4 goes into this. So we can think, okay, well, there's the square root of 4 times the square root of 2. And 96 is not as familiar, but 16 does go into that 6 times. That might be some guessing and checking there, but we're finding a perfect square that goes into this. So the square root of 16 times the square root of 6. And so square root of 4 is 2. So we have 2 root 2 times 4 root 6, and now we can multiplying our numbers that are not in the square root. 2 times 4 is 8, and then we have 2 times 6 is 12 in here, but we want to make sure it's simplified in here, and this one we are familiar with now, that this does or can be simplified more. So we have our 8, and we can split 12 into the square root of 4 times the square root of 3, and we get 8 times 2 times root 3, and that is 16 root 3. And so we see square root of 8 times the square root of 96 is 16 root 3. So that's the concept we're going to use here. This time we have some factors outside of the square root, and so we can multiply those. 5 times 4 is 20. If we were to try to simplify these first, this is a 14, which is 2 and 7. There's no squares that go into that, no squares that go into this. So what we can do is 14 times 6, or this is a case where the factoring will help, because we have, this is a 2 times 7, and this is a 2 times 3. And so we have a perfect square here of 2 squared times 3 times 7, 2 squared. And this one we know that's 4, that's a perfect square, so we have the 20. The square root of 2 squared is just 2. And then within the square root we still have the 3 times 7, which is 21. And so this is 40 root 21. We could have multiplied these together. So 5 times 4 is 20. 14 times 6 is 84. And then we could have tried to think of, well, what's the largest perfect square that goes into that? 4 does. I don't believe 16 does. So we can say, well, that's the square root of 4 times the square root of 21. And we know the square root of 4 is 2. So we can take the square root of 4 is 2 times the square root of 21, and we get the same thing. So that's another way to look through that one. So now we have fourth roots here. Fourth roots we want to find perfect, or numbers that are multiplied by themselves 4 times to get the numbers here. Well, first of all, we have a 3 and a 5 here, so that's 15. So we can automatically do that. And when we worked with fourth roots, we can try simplifying. I know fourth root of 8 does not simplify. 162, I'm not real familiar with that. So what we can do here is we can multiply these. 162 times 8. 162 times 8 is something. Actually, I'm not even going to figure it all out. It would end up being something, but let's do a factor tree to help us get factors of this. So 8, we know that's 2 times 2 times 2. 162, 2 definitely goes into that. That's 2 times 81. 81 is 9 times 9. And then that's a 3, 3, 3, and 3. So whatever this was multiplies to be 2 times 2 times 2 times 2, which that's a 2 to the 4th. So we have 2 to the 4th times 3 to the 4th. And so this turns out nice because we have the fourth root of 2 to the 4th times 3 to the 4th. Well, we're taking the fourth root, so what multiplied by itself 4 times gives 2 to the 4th? That's almost too easy. It's 2, because that's what 2 to the 4th means. And then the same idea here. What multiplied by itself gives us 3 to the 4th? Well, that's 3. And so this one, we end up with no radicals, so we have 15 times 2, which is 30, times 3, which is 90. Excuse me. And now the rest of these problems are going to use the same idea that we just worked with, but now we're going to apply them to when we have to use distributive property. And then we'll hit some special binomial things later. So we're just going to distribute. And so we have 3 times 5, which is 15, and plus 3 times root 7, which is just 3 root 7. We can't simplify that at all, and that's it. 15 plus 3 root 7. Same idea here, it's just that this one will end up simplifying some. So we're going to multiply this root 5 to each term. So this is negative 3 root 5. And then root 5 times root 5 is root 25. But we know that root 25 is 5. And so we have negative 3 root 5 plus 5. A lot of times we do like to put our, if it's a binomial, we like to put the rational number first, and then the irrational, the one with the square root in it, second. So again, what I mentioned before, just lots and lots of examples. Here we have the cubed root of 4. We're going to distribute that just as we did before. 6 times the cubed root of 4 minus, and we have the cubed root, 4 times 16 is 64. And is 64 a perfect cube? It is. We have, that's 4 times 4 times 4. So what times itself 3 times gives me 64? Well, that's 4. So I have 6 times the cubed root of 4. And then this is a perfect cube, so this is just minus 4. Again, looks a little bit new, but it's not new at all because this is still distributive property. This 3 needs to be multiplied by both terms. So 3 times 6 is 18. And then 3 times root 3 is 3 root 3. And now we're going to multiply this negative 5 times both terms. And we get negative 6 root 5. And then here, these are both in square roots, so we can multiply, and that's negative root 15. And there's no simplifying we can do here, so that is our final answer there. Once again, this one will be able to be simplified a little bit in the end, possibly. So we got 2 root 5, sorry, not 2 root 5, 2 times 5 is 10, and then plus 2 root 3. And then root 3 is going to be multiplied by both of these, so root 3 times 5 is 5 root 3. And square root of 3 times square root of 3 is square root of 9, which you probably know is just 3. We have some like terms here that we can add together because they have the same radical. The index is the same and the number inside the radical is the same, so we end up with that's going to be 7 root 3. And now I want to think a little bit here. The square root of 9, that's 3. And so we had a 10 plus a 3, and that's 13. So we have 13 plus 7 root 3. This one we can do the same thing, but it's going to end up being even simpler than that because we learned when we have something in the form a minus b times a plus b, it works out that that's going to equal the first thing squared minus the second thing squared. So it's going to be a squared minus b squared. And so that this problem here fits this form, and so we could multiply it out and it would work out just fine. So if you don't remember this rule, you just multiply it out, but it does make it nice and simple. This is going to be a squared minus, so the 2 squared minus the root 5 squared. Well, 2 squared is 4. The square root of 5 squared is just 5 because they're inverses of each other, so minus 5, and we get negative 1. And again, you could multiply that out and add like terms and you would still get that negative 1. Same idea here. It's like an a plus b times an a minus b. So it's going to be the first thing squared minus the second thing squared. And so this is 16 minus 12 because the square root of 12 squared, these are inverses, and you get 4. Very nice and easy to do if you recognize that form. This next one, we learned we can multiply this out. We could rewrite this, but one mistake, which I mentioned before, that people make is they just try to square both of these. It does not work that way. There is a pattern and a formula we can follow. It's not squared, we already squared it. So you can multiply it out, and you get 9 plus 3 root 5 plus another 3 root 5 plus root 5 times root 5 is root 25. Well, we know that that is just 5. And so we have 9 plus 5 is 14 plus, we really had the same thing here, so it's 6 root 5. And that's how we remember how to use this formula. We learned that if you square a binomial, so this is two terms, it's going to be the first term squared, so 3 squared. And then it's going to be the first term times the second term doubled. So 3 times root 5 doubled is 6 root 5. And then the last term squared. And so we get 9 plus 6 root 5. And this is just a 5. And then 9 plus 5 is 14. So we get the same answer a little bit quicker. So recognizing that formula is helpful, but again, you can do that either way. You can write it out and then multiply it out as the same as if you follow the formula. This one doesn't fit a special form, so we do have to go ahead and multiply this out. So we're going to do 5 times 6 is 30. 5 times negative 2 root 3. The 5 times the 2 is 10, so negative 10 root 3. Now we'll do these terms. That's a 2 times 6 is 12 root 3. And then this last one, we got a 2 times a negative 2, which is negative 4 root 9, because the square root of 3 times the square root of 3 is 9. But we know that that's a times 3. And so we have 30. A couple like terms here. Negative 10 root 3 plus 12 root 3 is a positive 2 root 3, and then minus 12, and so finally we have 30 minus 12 is 18 plus 2 root 3. And we've really gone through a lot of examples. Here's our last one. It's actually 3 things multiplied together. I usually prefer to leave this to the end, and we're going to go ahead and multiply these things out, and then we'll multiply at the end the square root of 7. So 2 times 8. So I'm going to leave the square root of 7 out here for right now. 2 times 8 is 16. Minus 4 root 3 plus 40 root 3. The 5 times the 8 is 40, and we still have the root 3. And then minus 10 times root 3 times root 3. Hopefully you realize that by now is just a 3. Could think of the square root of 9, which is 3, so times 3. That's all in there. Let's go ahead and simplify in here before we multiply by the square root of 7. This is a 30. So we have 16 minus 30 is negative 14. And then a negative 4 root 3 plus 40 root 3 is 36 root 3. And now we're going to distribute in this square root of 7. And so we get negative 14 root 7 plus 36. And root 7 times root 3, you multiply the 7 and 3, you get root 21. And that's our final answer to our final example. I know it was a lot of examples, but it's a similar process. It's just multiplying. You've multiplied binomials before, so that's nothing new. Just have tons and tons of examples.